everybody out there in Math Land. Today for third grade, we have a lesson involving looking at polygons that have the same perimeter but different areas. Okay, we're going to start on our second page, which is page 700. It's incredible that we're already on page 700, kind of crazy. Okay, so here's what we're going to do. We're going to find the perimeter in the area of rectangle A, and we're going to draw a different rectangle that has the same perimeter, and then we're going to figure out which one has the greater area. Okay, first of all, to find perimeter, you have to add up all the sides, right? 4 plus 6 with 4 plus 6. Okay, that gives us 20 meters. For finding area, you have to multiply length times width. So not addition, multiplying length times width. So therefore 6 times 4, that's 24 meters squared, or square meters. Okay, square meters. Now, for rectangle B, we have to come up with a combination of numbers that is also going to equal 20. For example, 7 plus 3 plus 7 plus 3. That means 7, 1, 2, 3, 4, 5, 6, 7, and 3 across. Like that, okay? So that would give us a perimeter of 20 meters. But then the area would be different because it would be length times width, 3 times 7, which would be 21 square meters. Therefore, this is rectangle A, rectangle B. Look at the area. This one's 24, 21. So which one has a greater area? This one, 24. So rectangle A. Okay, let me show you in another example. Find the perimeter in area rectangle A and draw a different rectangle that has the same perimeter. Which rectangle has the greater area? So for this perimeter, it would be 2 plus 5 plus 2 plus 5, which would give you 14 inches. The area would be 5 times 2, which will give you 10 square inches over here. So the perimeter also has to equal 14. So for example, I can have 4 and 3 and 4 and 3. Because 4 plus 3 plus 4 plus 3 also gives us 14 inches. And the area would be 4 times 3 equals 12 square inches. So rectangle B has the greater area. 12 is bigger than 10. Okay. Moving right along. Over here, we're going to find the perimeter. Same thing in the area. And come up with a different rectangle that has the same perimeter but different area and see which one's bigger. Okay, over here. 1 plus 10 plus 1 plus 10. Because as you know, this is 10, this is 1. This equals 22 centimeters. And then the area would be 10 times 1, which would give us 10 square centimeters. For this one, we're going to do, give me 1 second. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6. Okay, so this one's 5, this one's 6, this one's 5, this one's 6. So the perimeter is 5 plus 6 plus 5 plus 6, which also gives us 22. And the area would be 6 times 5, which would give us 30 square centimeters. Who has the greater area? Rectangle B, because 30 is bigger than 10. Over here, perimeter will be 3 plus 7 plus 3 plus 7, which would give us 20 meters. For the area, it would be 3 times 7, which would give us 21 square meters. For this side, it would be 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay, so perimeter would be 6 plus 4 plus 6 plus 4, which will give you 20 meters, so same perimeter, but the area would be 6 times 4, which will give you 24 square meters. 24 is bigger than 21, so this is rectangle B. Okay, it says draw a rectangle that has the same perimeter as the one shown, but with lesser area. What would be that area? So you need to come up with numbers that would equal 26 when added together, but it would be less by multiplying 5 times 8. Here's a technique that I suggest that you use. If you look at how much these two added up together, 8 plus 5 is 13. So come up with two other numbers that when you add them together, they equal 13. Let's see. You could have 7 and 6. You could have, let's see, 13. 10 and 3. So that's what I'm going to do. 10 and 3 equals 13. So 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I wanted to verify. And then 3. 10 and 3. So when you add this together, look at this. 10 plus 10 is 20. 23, 26. That's the same as this one, 26. But it's a different area because now it's 10 times 3, which is 30 square feet. This one would have been 40 square feet. So therefore, this one is less in area than that, fulfilling what they wanted us to do. On the back. A paleontologist has 12 meters of twine to rope off a rectangular section off the ground. How long and wide should be the roped off section so it has the greatest area possible? Okay. So, 1 second. So 12. It has to equal 12 when you add it all around. Look at this. 3 plus 3 is 6. 6 and 3 is 9. 9 and 3 is 12. And when you multiply these together, you would get 9, right? So he was the greatest area possible. She should make the roped off section be 3 meters. Because here would have been another, if she would have been doing like 5 and 1, for example, because this would have been 6 plus 6, which would be 12 meters all around. When you multiply these two sides, it would have only been 5, which is less than 9. Okay, so therefore this would be the best possible explanation for that. Newton has 16 feet of wood to make a rectangular sandbox. How long and wide should he make the sandbox so it has the greatest area possible? A square would be the best option, just like in the problem above. So that would be 4 in every side. So it should be 4 inches wide and 4 inches long. Because 4 times 4 equals 16, but also 4 plus 4 plus 4 plus 4 equals 16. Okay? Here we go. You and Newton are building forts. You each have the same length of rope to make a rectangular perimeter for the fort on the ground. Your roped off section is shown. Newton's section has a greater area than yours. Draw one way Newton could rope off his fort. 7 plus 3 plus 7 plus 3 equals 20. So you have to find another way for all the numbers to equal 20. Here's a way. 5, 5, 5, 5, because 5 times 4 is 20. So that's one way he could have done it. It says Descartes also builds a fort. He has the same length of rope as you to make the perimeter of his fort, so also 20. Descartes' roped off section is lesser area than yours, so less than 25. What could it be? 8 plus 2 is 10. 8 plus 2 is 10. 10 and 10 make 20, so I still use 20. But this area would be 16, which was less than 25, like in the previous problem. And this one's 21, just so you know. Okay, so I want you to do this lesson carefully. Have your notes with you when you do it and have an adult check your answers. Email me if you have any questions, and I'll talk to you later. Bye.